So I thought we would revisit this and try and clarify the operation of an injector. I was at the scrapyard the other day and I had an opportunity to pull an injector of an SX4, so I did, just to make the story a wee bit more complete, right? So if you recall, this injector tester, all it does is generate pulses in order to operate the injector, and the idea is you can use it for balance testing. I mentioned that in the last video, right? So I'll just give you a wee demo and you can hear it. Now it's operating the injector clearly. Just provides it a pulse so that the coil within the injector can pull up the pintle and operate the injector, yeah? But this doesn't quite simulate your car, okay? And I'll show you why. This is typically what you expect to see with respect to an injector pulse operating within the vehicle on your scope. You'll notice that it has a 12 volt supply, and in order to operate the injector, the control, the ECM in the case of the car, or the tester in the case of our setup here, actually pulls it to ground. So what I was demonstrating was it the other way around, and I hope that didn't misinform anybody or confuse anybody, because that's not the way the injector actually works in the vehicle. The way it works in the vehicle, as I said, is the control module, whether it be the tester or the ECM in your car, actually pulls it to ground, provides a coil on a ground on one side of the coil, allowing the injector to form the magnetic field, pull up the pintle, and then when it removes the ground, because the pintle is going to move and because the field is going to collapse within itself, and there's going to be a measure of self induction that is going to cause this spike. And this is a very characteristic spike that you'll see when you're actually, again, on your vehicle. So just to be as clear as it possibly can be here, guys, we have the power and the ground being applied to the control module here. Out of the control module comes the supply on the red line here. There's two wires going to the connector. The red wire, the red heat shrink line, has the 12 volts, and I'm actually back probed on the other wire, which is the switched ground line. So at the moment we have the 12 volts coming in through the coil, but it's ungrounded. That's why on the scope we actually see the supply voltage. It's not being switched to ground, of course, because the control mode is not active. And I've swapped to my modus here because initially I thought, is this a shortcoming of the Handtech? I wasn't sure. So let me just show you a demonstration here. I've just got it in auto at the moment, trigger wise, I mean. So let me change the trigger so it can actually hold the waveform. Let's go normal. Yeah, that's what we want, normal, yes. Okay, good. Okay, and let's try that again, and it'll actually hold the waveform for us. So I've set up the time base here, guys, that we're only seeing one pulse, although there's 50 pulses in the train here, but I want to just focus on this. So firstly, you'll notice that there's quite a bit of noise that this little test rig actually generates, right? And you'll notice there is no characteristic spike. That's a minimal spike. You can see it's only actually going up to 12 point, the max voltage there, 12.6 volts. Now, that's pretty minimal, right? Again, that battery's a wee bit on the low side, guys, and this introduces a bit of 1 volt drop in the system here. So the point is, that's a really minimal spike. And I think that's a function of the circuitry within the test rig here. It's protecting itself essentially, but it doesn't really simulate what the vehicle will actually do. You can see there's a noticeable difference between the size of the spike there and the size of the spike actually right here. And if you look at it, if you look at the width of that spike, the timeline wise, and if you look at the noise, it actually drops it here. So I think there's a degree of clipping going on inside this, maybe a zener, that cuts the spike in order to protect itself, in order for the unit to actually protect itself. So it's not quite like your car. And the reason I got the modus is, again, I was wondering, is this an anomaly that the Handtech is not quite capable of showing? But it's not. I can assure you that the display on the Handtech was actually very, very similar. In fact, I went into different modes with the trigger. Let me go into, right now it's just in normal mode here. So let's go to peak detect. And I'll try it again. and I'll show you a wee bit more detail in the peak detect mode, but not really much. You can see there's still only a minimal spike detected there. It changes the noise characteristics a wee bit, but minimal there. And I'm going to show you just one other trigger mode here. Get rid of the peak detect. Get rid of that, and we'll go to filter. Now, I'm showing you this for a reason, because I'm going to make a comparison on the Handtech. Get rid of that. We'll run it one more time, and you can see on the filter here, it gets rid of all the noise, but the peak is completely gone. The spike, the high voltage spike is completely gone. So in the Handtech scope, there is similar modes to the peak detect and filter. If you actually go to utility, you go to acquire. Hope you can see this okay, guys, on the display. You can see we're in normal mode here, which is just like the modus was initially. There's average, which is essentially filter. There's peak, which is essentially peak detect on the modus. And there's one other mode, which is high resolution, which I think just changes the sampling rates. So there is facility to actually basically do these same functions. You can invert, you can select these modes, and auto find is a bit like the auto function here. So quite similar in that regard. Let me just go back to the trigger mode here. I want to go into auto, and it will bring up, it doesn't need to trigger, so it will paint the trace. And you'll notice that it's actually painting at just the supply voltage, right, from the battery and through the rig. And again, I wanted to make it clear that the way this operates is it pulls it to ground in order to operate the solenoid, right? So again, I'll show it to you here. It's pulling it to ground in order to actually apply a ground to one side of the coil and operate the coil to form the magnetic field in order to pull the pin to operate the injector, right? I hope I didn't confuse people with, because I only briefly stated that I was just using this for pulse generation purposes, but it might have confused some people with respect to how it actually operates. So one last point of interest here, guys. This spike on your car, right? This can be quite a high voltage spike. Keep in mind this would be in and around 12 volts, battery voltage, let's say system voltage, right? This can be 50, 60, 70 volts. This cannot take 70 volts of input, right? Maximum is, it states in one of the publications from Handtech, is 30 volts. Now take that with a grain of salt. It doesn't say much more than that. Input voltage max says 300 volts, but at 10 times attenuation. Still looking for clarification on that, but if I were you, if I was actually using this on my vehicle, right, make sure you use an attenuator, right? This is a 20-to-1 Handtech attenuator, because you do not want that spike to damage your scope. In closing, this does not perfectly simulate your car, right? Because again, the spike is just not going to be normal, as you can see there, right? And but I was pleased that the motor showed basically the exact same trace as the Handtech, so I was worried that the Handtech, maybe it was a shortcoming in the display of some way, shape, or form, right? But it's not. So I've showed you the trigger modes, how they're very similar with respect to the average, with respect to the filter modes, the peak detect. I've showed you the distinction that that a trace will actually have when actually on the vehicle. Is a very distinct trace, but that is not going to be there from this simulator, guys. Okay, so just to make the story complete. Automotive oscilloscopes, waveform analysis by Graham Stokes. Absolutely fantastic, worth every penny. Always liked the 944. I think it could be fixed up. What do you think? Look at this. Looks like we've had a bit of fire under the dash. Bummer, man.